2 volt. So by looking at the direction of the diode, we can identify in which direction the circuit will be clamped, whether it is towards the positive or the negative. And we have to remember that the span of the signal or the swing of the signal should be remain constant as it was in the input waveform. Now similar to this is this circuit where we have the same input waveform, but now we have changed the direction of the diode. Now it is pointing towards the upward side. So keeping that in mind, what we can say that the waveform will be shifted towards the upward direction, towards the positive side. So the whole signal has been shifted towards the positive side, but still the swing of the signal is 2 volts. So by just looking at the orientation of the diode, you can check the output waveform whether it is correct or not. But you have to solve every step of it to obtain this particular output. Now let's come to this circuit where we have this particular diode which is pointing downwards. That means the waveform will be shifted downwards. And if there is no external DC power supply and we are considering the ideal diode, then the whole input waveform will be shifted towards the negative direction, downward direction. But here we also have a battery V1, which is whose positive point polarity is upward and negative is downward. So it is saying that we have to shift the resultant waveform by V1 voltage in upward direction. So here, this was the input waveform that we obtained. And in the same circuit, we have connected one battery V1. So this is saying that you have to shift this particular output waveform by V1 amount, which we have done in here. You can see that here. This one. So we have shifted it by V1 towards the upward direction. Now, if you take the same circuit, not this one, but this same circuit. This circuit, and now you add an additional battery, but the polarity is like this. So in that case, your signal, which was supposed to be all over in the whole signal should be present in the negative direction due to presence of this diode. Now there will be an additional shift of V1 volt in the negative direction also. So your signal has been shifted toward in the negative direction that you can see here.
Excuse me, sir.
Yes.
सर फर्स्ट वाले डायग्राम में पहले वाला जो वो आया है ग्राफ जैसे रिवर्स बायस में आया है जो उसके बगल में एक और 2 वोल्ट का अपोजिट साइड में वो आया है, वो कैसे आया? मतलब
this is not 2 volt, this is 2 times of V, this V plus V.
सर तो फर्स्ट वाला तो समझ में आ रहा है, लेकिन सेकंड वाला कैसे आया? मतलब ग्राफ
this one
ऐसे सर फर्स्ट वाले डायग्राम में 2 ब्लॉक्स बने हैं। एक तो फर्स्ट वाला जो आपने उससे बताया है कि वो 2 टाइम्स ऑफ V है, और उससे जस्ट बगल में एक और 2 वोल्ट का हाफ वाला बना हुआ है, वो कैसे बना है?
This one, can you see the cursor?
No sir, in the first diagram only.
First diagram is this one.
Yes sir. सर ये आपने फर्स्ट वाला ब्लॉक बना दिया है, इसके जस्ट बगल में एक और 2 वोल्ट का ब्लॉक बना हुआ है, ये कैसे आया?
ये?
Yes sir.
No, this is not a block. This is just telling us the swing of the signal.
Okay.
This is maximum voltage minus 2 volt, and this is telling us the swing of the output waveform.
Okay sir, thanks.
Okay. So if we have connected V1 battery like this, then your signal will be shifted by V1 amount more into the negative direction. Now take this particular circuit, that is positive clamper circuit, which is this one. If there is no external DC power supply, then your whole input waveform will be shifted towards the upward direction. But if we have an additional battery of V1 here, which is also its polarity polarity is like that, if its positive part is upward and negative part is downward, then we will have an additional shift of V1 voltage right here in the signal. And if the polarity of the V1 is opposite, then that means this output waveform that was a resultant of this only diode being present in the circuit, that will be shifted by V1 amount, but now in the negative direction, which is here. But in all the circuits, you can see that the span of the signal is 2 volt. In here also, and here also. So there is no change in the waveform, in the shape of the input waveform. It is just the DC content, DC level of the input signal that has been changed, and nothing else. If somehow during the explanation your output waveform has a different shape than input, that means that is not the output of a clamper, or you have solved it incorrectly. Okay, so these are all the circuits of clamper, and there should be more complex diagrams when we can have more than one diode, or we can have more than one DC power supply. So you just have to be careful that you have to remember the steps that we use to solve the clamper circuit. That taking the first cycle in which your diode is on, and then taking the off side, and then remembering what amount of voltage will be appearing across the capacitor, and then assuming that this voltage will be maintained during the off state of the diode also. Okay.
Excuse me, sir.
Yes.
सर थर्ड में इसका जो स्पैन है वो 2 वोल्ट से ज्यादा है 2V से.
नहीं, कहाँ पे, कौन सी डायग्राम में?
थर्ड में सर, लास्ट में.
ये तो इन दोनों में
लेफ्ट साइड पे यस इस पे.
नहीं, अब ये देखिए ना, इसमें मिनिमम वोल्टेज आपकी सिग्नल की कितनी है? -V1 वोल्ट.
ओके, मिनिमम. ठीक
है, और मैक्सिमम वोल्टेज जो आपको मिलेगी वो मिलेगी -2V + V1 वोल्ट.
ओके,
ब्रैकेट में साथ में. ठीक है, तो आप जब उसको सब्ट्रैक्ट करोगे तो V1 से V1 सब्ट्रैक्ट हो जाएगा, और स्पैन आपका सिग्नल का यही रहेगा. Just because it is lying below it doesn't mean that it is lying from 0 to 2V + V1.
मिनिमम जो है V1 है.
मिनिमम वोल्टेज देखिए इसमें ये है, आप इस पॉइंट पे मिनिमम वोल्टेज आपकी ये है, और मैक्सिमम वोल्टेज आपकी ये है. आपको 0 नहीं मानना है.
ओके,
ठीक है, तो दिस इज योर माइनस ऑफ V1. ये यहाँ पे पहले आपकी थी -2V. ठीक है, अब ये आ जाएगी -2V - V1. तो दिस इज इक्वल टू दिस वैल्यू. अभी आप यहाँ से इसका स्ट्रिंग निकालोगे, इसका स्पैन निकालोगे, तो इसमें से जब इसको सब्ट्रैक्ट करोगे तो दैट विल बी इक्वल टू, इसमें से इसको सब्ट्रैक्ट कर दीजिए मैक्सिमम टू मिनिमम, दैट विल कम आउट टू बी 2 times
2V. ओके, थैंक यू.
ओके. Okay, now this is one thing that I also told you to do at home, and today I will also discuss it in brief, and you have to solve it on your own. In here we are using the sinusoidal input signal, and this is the clamper circuit, and its output should look like this. So to remember how we have reached here is that you consider that you are taking the square voltage, rectangular pulse is your input, with the same maximum and minimum voltage. If this was your input and this was your circuit, so based on this circuit, what you can say that the waveform will be shifted upwards, and if there was no additional battery here, then your whole signal should be present in the upward direction. But now we also have one 10-volt battery in the with minus polarity in upward direction. So that means the whole waveform that was supposed to be lying like this This is the output without the external DC power supply, and right now here we will have 40 volt. But due to the presence of this battery, what we will get? We will get this type of output, where this will be your 30 volt and this will be minus 10 volt, keeping our span equal to 40 volt, which is also here 40 volt. Now, if this was your input waveform, then this should be your output. So just keeping that in mind, your sinusoidal output will also be behavior will also be the same. Your circuit will be the output of the circuit will be like this. ठीक है, तो आप यहाँ पे भी देख सकते हो. This is the line for 0 axis. अगर यहाँ पे आपका 0 एक्सिस होता तो ये आपके आउटपुट तब होती जब आपका यहाँ पे सिर्फ एक डायोड होता एंड देयर वाज, अगर यहाँ पे कोई भी एक्सटर्नल डीसी बैटरी नहीं होती. एक्सटर्नल डीसी बैटरी है, then this signal has been shifted by 10 volt in the negative direction. Sorry. This is if there was no external DC supply, then your output would look like this. This will be your axis for 0. Your whole input waveform, output waveform will lie above the 0 axis. ठीक है, बट यहाँ पे 10 वोल्ट की बैटरी है तो उसकी वजह से आपकी नीचे की तरफ शिफ्ट होगी. दैट्स व्हाई द आउटपुट इज लाइक दिस. तो कोई भी इसके अंदर चेंज नहीं होगा. दिस विल आल्सो बिहेव लाइक सेम जो हमारा रेक्टेंगुलर में था उसी तरीके से. बट योर एक्सप्लेनेशन विल बी अ लिटिल बिट डिफरेंट. सेम स्टेप्स आप फॉलो करेंगे. रेक्टेंगुलर में हमारा जो इनपुट वेवफॉर्म है वो सिर्फ दो ही वैल्यूज लेता है, एक तो 20 वोल्ट, दूसरा -20 वोल्ट. Whereas in sinusoidal it keeps on changing. So in your expression, instead of having a constant, you will have Vi, and depending upon the Vi, your output waveform will also change. But the span will be same as it was in the
Yes, sir.
in case of rectangular. Okay. So you please solve this kind of problems on your own, and इसमें आपको थोड़ा सा कुछ नई चीजें सीखने को मिलेंगी. ठीक है, उस सर्किट को जब सॉल्व करने लगोगे आप, तब आपको कुछ नई एक्सप्रेशन आपके सामने आएंगे. So this is the diode application as clamper. Now move on to the next topic, which is Zener diode application. Okay, so Zener diode, I think you guys remember that here in Zener diode, in the reverse bias region, there is Zener breakdown instead of avalanche breakdown, and your Zener breakdown occurs at low reverse bias voltage. So if your VI characteristics curves of the diode are like this, then during the negative half cycle, during the reverse biasing situation, the characteristics of Zener diode is something like this. And this occurs at Zener voltage, represented as this point, after which the breakdown has occurred, and after which the amount of current flowing through the diode is very high. This is represented as VZ. The forward bias characteristics is similar to the normal silicon diode or PN junction diode. Okay, so the application of Zener diode is generally in reverse bias situation. If we are using Zener diode, we will use it in the reverse bias region. There is no point of using the Zener diode for forward bias regions. For that, we can always use the normal diode. Okay, that is the first point. And the second point is, similar to the PN diode, the Zener diode will also be in on state and off state. Now, because we are using the diode in the reverse bias direction. So in the reverse bias direction, the equivalent circuit of the diode that we generally use is an open circuit situation. Open circuit. This is the equivalent circuit that we use for a normal diode in reverse bias situation. But in Zener diode, this will be something. This will be quite different. Why? Because we know that in normal diodes, the breakdown occurs at thousands of the voltage, negative voltage, and we are not operating our diode in that particular range. So till then, the current flowing through the diode will be zero. That's why we are taking it as open circuit. But your Zener diode, in Zener diode, the breakdown occurs at in the range very near to this axis, current axis or voltage axis. This is current axis ID. This is voltage axis VD. So this value is very close to the zero. So this is around 5 volt, 8 volt, 12 volt, 16 volt. This kind of values we have for reverse breakdown voltages, the Zener voltage. So if in our circuit, in our network, somehow we have made the voltage across the Zener diode in the range of these values, then our diode will be on. And that is the first condition or the equivalent circuit of the diode. This is the equivalent circuit of the Zener diode when it is on. Now it is on doesn't mean that it is in forward bias region. It is in the reverse bias region, but it can still be on if the input voltage is greater than Vz. Okay, so if input voltage is reverse bias and if it is greater than Vz, then your diode will be on. And once the diode will be on, then we will replace the diode with this equivalent circuit, which is a battery with polarities like this. इसकी जो polarities हैं वो भी आपकी different हैं as compared to the normal diode. नॉर्मल डायोड में हम अगर हमारा ये डायोड होता है इसको हम रिप्लेस करते हैं, इसको हम रिप्लेस करते हैं ऑन स्टेट में लाइक दिस. एंड द रीजन फॉर दैट इज द नॉर्मल डायोड इज ऑन ओनली ड्यूरिंग द positive biasing, the forward biasing. But here we are taking the diode in the reverse bias situation, and if we want to replace it with the equivalent circuit, then we have to use this kind of polarity. So this is the first thing that you have to remember, that in the on state, your diode will be replaced with this equivalent circuit. In off state, it will be replaced with open circuit. Okay, and diode will be on if your input voltage V is greater than or equal to Vz. So you can also see here that the input voltage V, it is less than Vz, then your diode is off, and it is on only in the case of reverse bias voltage becoming higher than the Zener voltage. So this Vz is your Zener voltage for the diode. Okay, so these are the equivalent circuits of the diode, Zener diode, and we will replace these by finding out whether our diode is on or off. Now, how to do that? So, any circuit consisting of Zener diode, there are two steps to follow. The first step is to determine the state of the Zener diode by removing it from the network and calculating the voltage across the resulting open circuit. So if this is our circuit that we have to solve, then we will replace or remove this diode and make it as is an open circuit. So this we can see right here, we have done it. We have removed the circuit, we have made this, we removed the Zener diode and we have made this open circuit. Now we will calculate the voltage between these 2 points, V. Okay, to calculate that, this is a simple circuit. These are two branches are in parallel, this one and this one, this branch and this branch. So whatever voltage drop is occurring across this branch, that will be occurring across this branch also, these 2 points also. So what you have to do is you have to just calculate the VL. Now VL is your voltage drop across the load resistance. There is one resistance right here, and then one load resistance right here. And this is the circuit for a basic Zener regulator. So it will we will see that how it regulates the amount of voltage that can appear across the load. How it can act like a voltage regulator. So one load resistance, one normal resistance, and one diode. Replace the diode with the open circuit. Just remove the diode. Calculate this value of V, which is same as the voltage drop across the load resistance R. Now, if you want to calculate the value of VL, you can simply use the voltage divider rule. So, or you can use the circuit analysis. That VI is your input voltage. This is R, and there will be only one type of current flowing like this. So this current will be equal to VI divided by R plus RL. If this is the current flowing through the circuit, and now we have to calculate the voltage drop across this resistance RL, we will simply multiply it with the RL. So this is equal to VL, and this is also equal to V as shown in here. Okay, so this was simply this is the amount of current that will flow through the circuit.
सर
Yes, multiplied it with the resistance. Yes.
सर ये जीनर डायोड पैरेलल तो वीआई के भी है, तो वो वोल्टेज क्यों नहीं आ रही वहां पे?
क्योंकि यहाँ पे हमारा एक एक्स्ट्रा रेजिस्टेंस भी है यहाँ पे.
ओके सर.
इस ब्रांच में हमारा एक बैटरी है, एक रेजिस्टेंस है. अगर आप इसको सोल्व करोगे तो भी आपका वही आंसर आएगा. तो सिंपली राइट वी आई माइनस वोल्टेज ड्रॉप अक्रॉस दिस रेजिस्टेंस, एंड नाउ दैट इज ऑल्सो इक्वल टू द वोल्टेज ड्रॉप अक्रॉस दिस रेजिस्टेंस. Okay, so this is the voltage that we have calculated across the diode that will appear for this particular circuit. इस सर्किट में हमारी जो वोल्टेज ड्रॉप दिखाई देगी across the diode, that will be equal to this. Now we will check whether this value V is greater than VZ or not. If this voltage V, if this is greater than VZ, that means the Zener diode is on. Why it is on? Please look at the polarity of the input signal. This is positive, this is negative, and this is the N side of the diode, this is P side of the diode. So this is your reverse biased diode. Okay, your Zener diode will always be in reverse bias situation. Now in reverse bias situation, you have to look at the magnitude of the input waveform. So if it is greater than Zener voltage, then your diode is on. If it is less than Zener voltage, then your diode is off. Once you have find out that whether your diode is on or off, then we will replace the diode with its equivalent circuit. Right now we have not replaced Zener diode with open circuit or short circuit. हमने उसको replace नहीं किया है. We were just trying to find out how much voltage this Zener diode will be developing across the Zener diode. कि वो कितना experience करेगा voltage. Okay, now comes the second step, which is substituting the appropriate equivalent circuit and solve for the desired unknown. So if your V is greater than VZ, if V, that is voltage across the Zener diode, it is greater than or equal to VZ, so we will replace it with the equivalent circuit, which is replacing the diode with a battery with polarity like this. तो हमने Zener diode को find out किया कि वो on रहेगा in this particular connections in this network. We replace with a battery equal to VZ. Now you simply calculate whatever is asked or whatever unknowns are left. If this is Vz, then you also know that the voltage across the load resistance will also be equal to Vz, because these two are in parallel. So that is the first thing, VL equal to Vz. VL हमने वैसे भी पहले फाइंड आउट किया था, ठीक है. Now what is the meaning of this statement right here? पहले हमने ये फाइंड आउट किया whether your V is greater than Vz or not. If V is greater than Vz, this was also equal to VL. In that case, your VL will become equal to Vz. That means this load will never experience voltage greater than Vz. As soon as the voltage across this load resistance will be greater than or equal to Vz, then that will be the voltage experienced by the Zener diode, and that will turn on the Zener diode, and then the equivalent circuit will be like this. And this load resistance will not experience higher voltages than Vz, and that's why the name of the circuit is voltage Zener diode as voltage regulator. So it is regulating the maximum voltage that will be experienced by the load by turning itself on when the input voltage is higher than Vz. Okay, so that the load voltage will be Vz. Now you have to find out the current. Now to find out the current, what you have to do is you find out these three things. First, find out the IL. If you know the voltage drop across the load resistance is equal to VL, then you can simply find out IL using this formula, that IL is equal to VL by RL. Okay, now you have calculated the value of VL here. Input voltage is VI. There are only three components in the network. Sorry, two components in the network. So voltage drop across this plus voltage drop across this, that will be equal to VI. VI is given, VL has been calculated. So voltage drop experienced by the R will be VI minus VL. And if this is the voltage that has been experienced by the resistor, then current flowing through the resistor will be equal to this. So this is the value of IR. Now you have calculated the value of IL, you have calculated the value of IR. IR has been calculated, IL has been calculated. Now you know the sum of all the currents leaving a particular branch and entering the branch, that is also equal to 0. So at this particular node, this current is entering from here, and this is divided into two parts, this one and this one, IZ. So IR is equal to IL plus IZ. From there you can calculate the value of IZ like shown in this expression. So you can calculate the value of the current that will flow through the Zener diode. Now VZ has been given, IZ you have found out. Now you can calculate the power dissipated across the Zener diode. That will be simply multiplication of VZ and IZ. And in the diagram, in any diagram, when in any circuit where you have Zener diode, you will be given two things. One will be VZ and another will be PZM. VZ is your Zener voltage and PZM is your maximum power dissipation that this Zener diode can withstand. अगर आपका यहाँ पे 2 वोल्ट लिखा हुआ है तो 2 वोल्ट तक की पावर डिसिपेट कर सकता है, विथस्टैंड कर सकता है डायोड. After that the diode will burn out and it will not work properly. So you have to make sure that the current through the Zener diode will never cross a value such that the power dissipated across the diode is higher than PZM. So you simply calculate PZ. If it is greater than PZM, then you will say that the diode will not work, it will burn out. Okay, so what you have to do is simply replace the diode with the equivalent circuit and apply the circuit analysis find out the different values of current, find out the current through the diode resistance, and calculate the power dissipation. This you have to do when the diode is on. If your diode is off, then you don't have to do anything. This was the case when the diode will be off. Simply डायोड अगर ऑफ है तो यहाँ पे आपका जो करंट है वो फ्लो करेगा VI डिवाइड बाई R प्लस RL, उसमें आपको कोई चेंज नहीं आएगा। ठीक है, तो एनी डाउट टिल नाउ?
नो सर।
हम एक न्यूमेरिकल कर लेते हैं, थोड़ा और क्लियर हो जाएगा। ठीक है, सो दिस इज द क्वेश्चन दैट यू आर गिवन, that for the Zener diode network shown in figure 2.109, you have to determine VL, VR, IZ and PZ, and then you have to repeat the first part by taking the load resistance value equal to 3 kilo ohm. ठीक है, तो आप उसी स्टेप से चलिए। The very first step is deciding whether what should be the voltage experienced by the Zener diode. तो उसके लिए आप क्या कर सकते हो? Simply replace it with an open circuit, remove it out from the circuit, and voltage experienced between these 2 points will be your V. अब आप बताइए यहाँ पे कितना आएगी उसकी वैल्यू? This is the circuit for determining the value of V, and you have to tell me the value of V that you have obtained. V is equal to what? Yes. This V will be equal to VL. These two branches are in parallel. Okay, the first thing you do is you write this as like this. V is equal to VL. Now, what is the value of VL? That is current through the resistance IL into RL. ठीक है, now what is the current through the load resistance? That will be equal to VI divided by R plus RL. That will be the amount of current flowing through the diode load resistance. Multiply it simply with the load resistance. Now tell me what value did you get?
8.72.
How much?
8.727.
8.727 volt. Now you have to check whether this voltage V is greater than VZ or less than VZ. VZ आपका यहाँ पे दिया हुआ है. Let me show you it again. This 10 volt. Okay, so that means VZ is V is less than VZ. So your diode, Zener diode will be off or on?
Off.
Off, sir.
Off. Now, if Zener diode is off, then the same circuit can be will be your equivalent circuit. Now you can simply tell the calculate all the values. VL आपने already calculate कर लिया है. यहाँ से आप IL भी calculate कर सकते हो. IL in fact आपने पहले ही calculate कर लिया. This is IL. VI divided by R plus RL. That will also be equal to IR. इस केस में आपका जो IR होगा that will be also equal to IL. क्योंकि सेम करंट आपका ये वहां पे है, वही आपका आगे जा रहा है। एंड व्हाट विल बी द वैल्यू ऑफ करंट थ्रू द जेनर डायोड IZ? Yes,
0.
0. Why? Because it is open circuit. No, it is 0. That's why your IR is equal to IL. So now you have calculated all the values. You have calculated the V experienced by the diode, IZ, IR, and IL, and VL. Okay, so now you have done the first part. That is when your RL was equal to 1.2 kilo ohm. Now your RL is equal to 3 kilo ohm. This is your circuit for that. Now your RL is 3 kilo ohm. Now you have to calculate all these things again. So first thing same, you have to calculate whether your diode is on or off. तो यहाँ पे आपकी V की वैल्यू कितनी आएगी बताइए? If you simply replace this circuit with 3 kilo ohm,
Sir, 12 volt.
then the value that you get here is how much? This will be equal to 16
12
divided
12
by
volt.
4
12
into, yes, 12 volts.
So
So now you have to check whether 12 volt is greater than VZ or less than VZ.
less than
greater than
VZ आपका कितना था?
10
10.
10 volt. So your V is greater than VZ.
greater than होगा greater than
Okay, so now your diode will be
on
on. So if your diode is on, then you have to replace it with its equivalent circuit, which is shown in this figure. Now this circuit will be your equivalent circuit. So now again calculate all these things. Now VZ is equal to 10 volt. So VL will also be equal to VZ. ये आपको बैटरी लग गई है बीच में पैरेलल में. So the VZ, VL, the voltage across the diode will be equal to VZ, which is equal to 10 volt. जब हमने कैलकुलेट करके देखा तो हमने देखा कि वो 12 वोल्ट जा रहा था, बट व्हाट रियली हैपेंस इज 12 वोल्ट तो जा नहीं पाएगा क्योंकि 12 वोल्ट से पहले आपका डायोड ऑन हो जाएगा 10 वोल्ट पे ही. तो ऑन हो जाएगा तो उसके बाद द वोल्टेज एक्सपीरियंस्ड बाय दिस लोड रेजिस्टेंस विल बी इक्वल टू VZ. So that will become 10 volt. That is the first parameter that we have calculated. Now if you have calculated VL equal to 10 volt, then you can calculate the IL, which is simply equal to VL divided by RL. So that is 10 divided by 3 kilo ohm. ठीक है, यहाँ से आप उसकी वैल्यू निकाल सकते हो. So this will come out how much? 3.33 milliampere. 3.33 milliampere. Now you have calculated IL. You have calculated VL. If VI is 16 volt and 10 volt is dropped across the resistance RL, then how much voltage drop will be across the resistance R?
6
6.
6. So VR will be equal
6
to VI minus VL. So that is equal to 16 minus 10 equal to 6 volt. So another parameter you have calculated. Now if VR is 6 volt, what will be the value of IR? VR divided by R. So this is
6
equal
into
to
6 or minus 3
6 milliampere.
yes sir
Now if IR is 6 milliampere, this is 6 milliampere, and this is IL. This is 3.33 milliampere. So you can calculate the value of IZ.
$2.66.
So IZ will be equal to 6 minus 3.333.
2.67.
How much? 2.67 milliampere.
Yes.
Milliampere. Now you have calculated the value of current. You have calculated the value of voltage across the Zener diode. So what will be the power dissipation in this diode? VZ
VZ, IZ.
into IZ. So VZ was equal to 10 volt and IZ was
2.67 milliampere.
2.67 milliampere. So this comes out how much watt में convert करो आपको कितना आया?
26.7 milliwatt आया.
26.7 milliwatt. That is the value of PZ. Now you check it with the specification that is given in the circuit. PZ maximum is 30 milliwatt. So up to 30 milliwatt of power dissipation is allowed in the Zener diode.
Yes, sir.
Okay, so if your PZ is less than PZM, that means the diode can withstand this power dissipation and will act as a voltage regulator for this particular network or circuit. ठीक है, अगर आपका ये कम ज्यादा आ जाता तो उस केस में हमें कुछ इसमें चेंज करना पड़ेगा. ठीक है, वो हम नेक्स्ट क्लास में देखेंगे आपको. दिस इज हाउ यू सोल्व दिस क्वेश्चन रिलेटेड टू द Zener diode.
अगर ज्यादा आ जाएगा तो क्या करना होगा?
ज्यादा आ जाएगा तो पहली चीज तो हम यही लिखेंगे कि this diode cannot be used for in these particular connections we cannot use the diode as a voltage regulator. तो उसमें हम क्या करेंगे? We will try to find out a maximum limit of the external load that we can use. कि इससे ज्यादा का रेजिस्टेंस अगर आरएल को यूज किया तो डायोड जो है वो बर्न आउट हो जाएगा. So we will find out the range in which your diode will be operating successfully, and the range will be of this particular load resistance. इसकी एक मिनिमम वैल्यू होगी, इसकी एक मैक्सिमम वैल्यू होगी. Within those range, this diode will act as voltage regulator. Okay. So I am ending this class now. If you guys have any doubt, you can tell me now.
No, sir. Thank you.
Excuse me, sir.
Yes.
Sir, I am a new student, and sir, I want to know the procedure to cover my backlog.
Okay, you can cover the rest of the previous work by going to the LMS portal. There you will find different lecture videos. So first you go to the syllabus. There you will find the different topics that you have to cover, and you can match those topics with the video content that is made available to you.
Okay, sir.
Okay, I have also uploaded the recording of this class also on the YouTube. You can you can take the link from any student in the class.
Okay, sir. Sir, and what about the tutorial submission and lab practical submission?
You solve those numericals, and you will get some extra time to submit those.
Okay, sir. Thank you.
Which group is yours?
MP1.
Okay. So I think your tutorial is with me, so you can submit it later on. But you have to talk to your lab teacher for the lab submission.
Okay, sir. Thank you, sir.
Okay.